So I'm going to talk about, the title's a little bit, I'm going to talk about release engineering, best practices at Google, but I'm also going to talk about how we release software and the role that best practices play in that. And so, yes, I'm a senior release engineer, which officially makes me an SRE. So what is a release engineer? Even within Google, if you talk to different people, they have different ideas about what a release engineer is. And so I'm going to define that for the purpose of my talk so that we're talking about the same thing when I talk about a release engineer. So release engineering at Google is the discipline of building and releasing software. And this talk is going to cover that end-to-end. The skill set for a release engineer, what we look for when we hire release engineers, development, configuration management, test integration, and system administration skills. The development's becoming more and more important, just like for SRE. SREs at Google spend a good amount of their time doing development work. The same thing is true for release engineering. We consider ourselves to be experts in source code management, compilers, automated build tools, package managers, and installers. And you notice when you look at this, it covers end-to-end, from source code to deployment. So what are the roles of a release engineer? We know what a release engineer looks like, what the skill set is, but what do we actually do? We define best practices to ensure consistent and repeatable processes. Google, we rely on having consistent and repeatable processes. It's impossible to do things at scale and release thousands of projects and releases on a regular basis if we can't guarantee that our processes are consistent and repeatable. We make sure our tools do the right thing by default. Software developers and SREs should not have to worry about things like release candidate naming, package versioning, and so forth. Our release tools should just do the right thing by default so that they can focus on things like feature sets, deployment processes, the right decisions, when to release, and so forth. And we also, as I alluded to, we spend a lot of time developing tools. Our build automation tool that I'm going to talk about in a few slides was developed by release engineers. Project metrics, we have tools that do everything from monitor when do features get deployed into production to how many bug fixes does a specific release have. So we're very interested in those metrics because, well, one, we're Google, we like to measure everything. But this it helps us develop better best practices and release processes. We work with the SREs and project teams to develop strategies for deployment. I'll talk a little bit more about how these individual teams work with respect to making decisions about this. But I work with project teams, I work with SREs. It really depends on the project who I'm engaged with on those teams. So here's our philosophies. Here's these 4 areas kind of make up the basic philosophy of release engineering. And I'm going to go into each one of these in more detail now. A self-service model. It's important that teams be self-sufficient in order to work at scale. We have thousands of projects that we release. And if there's a bottleneck because they have to go through a gating team or decision makers about when to release, that's not going to scale. So teams are empowered to make decisions about when and how often to release. And that's critical to us releasing a high velocity and being able to roll features out as quickly as we need to. So know what that is. Go away. Okay. Okay, release processes can be automated to the point of minimal effort. And ideally, they're automatic, just not just automated. In other words, the release processes happen on a regular basis. Engineers don't get involved unless there's an actual problem. High velocity. You hear a lot about high velocity in the industry now. We believe that frequent builds, well, we know, it's a fact. Frequent builds have fewer changes between releases. And so we strive for having, and it makes it easier to troubleshoot problems because incrementally between each release, fewer things have changed. When there's a problem, you can quickly focus in areas that have changed as a potential source for the problems. Some teams, they build hourly or daily, and then they decide which builds to release based on either feature sets or on test results. And it varies wildly from team to team how frequently they do build. Usually it's at weekly or faster. A social builds hourly. I'm in our infrastructure organization, and many of our projects, they have nightly builds, and then many of them also only have weekly builds. There again, it's up to the teams to decide what their frequency should be. We also have teams. Dan Klein did a talk last year at LISA on push on green. He also wrote an article for Login about push on green. And other teams have adopted a push on green philosophy. If all the tests pass, ship it. And I'll talk a little bit later about what projects we believe as release engineers are appropriate for this deployment model. So Hermetic Builds. I must confess, when I first started at Google, I wasn't sure what was meant by Hermetic Builds. And I looked it up, and I found this definition on Wikipedia. And I loved the second one because it seems like sometimes in engineering, what we do, is a mix of alchemy, astrology, and I had to look up theosophy, and that's a type of divination. But anyway, I love that definition. But when I talk about Hermetic, I mean the first definition, complete and airtight, and I'm going to talk in a minute about exactly what we mean by that. So our build tools must ensure consistency and repeatability. If I do a build at a specific revision level from our source code repository, and another person does the same build, we should get identical results, even though we might be building on different machines. And so that's essential to the way we release software and the way we do things at scale. And I'm going to talk more about this later. So our builds are insensitive. It doesn't matter what versions of compilers and libraries and so forth that are installed on your machine. We have basically build machines that do the builds, and the build requests go to these build machines. By default, the version of the compiler and so forth is the same revision as what you're running out of the source code repository. And these tools actually get built and used for the build. And so because, one, it's a service, and because we make sure that our build process is self-contained, it doesn't really matter where you are when you request the build, what machine you're logged onto. And this is essential to us being able to have reliable releases. Our build tools are versioned. And so what that means is if I have to do a bug fix on a project that was released a month ago, when I do that, the same version of build tools will be used as was used a month ago. So we don't have to worry about incompatible features in our compiler that may have happened in the past month, or unexpected changes because of new features, not just incompatible features. So we also have enforcement of policies and procedures. And we've got access control lists and checks that determine who can do what end to end. So for source code, every source code change requires a review. And we have an internal tool we've developed that makes this very easy. It's just part of the developer workflow process. And you submit a change, it automatically gets sent out for review, and once it's reviewed, it can be automatically submitted, or you can manually submit it, depending on how you requested. And so that catches many problems very quickly. And so during the release process, we can define what actions are performed, what tests do you want to run, what types of packaging do you need? Are there additional tests besides the unit tests or the system tests you want to run? And so we've got permissions that are in place to determine who can define this. This is really important when you look at our SOX projects. Within Google, only release engineers are allowed to make changes to SOX projects to guarantee that we have the separation of duty that's required. Who can create a release? And related to that is who can define which location in the source code repository or which version can we use to do the release? And who can deploy a release? You know, when I'm talking about deployment in the we have lots of different kinds of deployments at Google, but for the purpose of this talk, I'm talking about deploying code onto our production machine that affects production services that our customers see. And who can make changes to the build configuration file? And I'm going to talk a little bit more about what that file is and how it's used in the build and deployment process. Continuous build and deployment. You hear a lot about that. That's kind of a buzzword these days. But it's very important, and it's very important to the way Google releases software. We have a, Google is all about NIH. Because of our scale, we've had to develop all of our own tools to do things. We just can't download open source and compile it and start using it. We've had to write our own tools. So we've written an automated release system called Rapid. I'm going to talk about Rapid in more detail. And this leverages the Google technologies we already had in place. And that allows us to do builds that are scalable, hermetic, and reliable. And also, I should add, automatic. So building. So Blaze is our build tool of choice. And I gave a talk here last year about MPM, Midas Package Manager. And someone asked me when we were going to open source Blaze, and we have. And it's been open sourced as Bazel. And Blaze allows engineers to define build targets, for example, a .jar file, and dependencies that are needed in order to build the specified targets. And both are built automatically. When you do a Blaze build on a specific target, everything, all the dependencies get built automatically in our build services, not on your local machine. They get sent off to the build services, and I have a drawing that shows that. Then we have rapid configuration files that specify these build targets and test targets and what flags should be passed in order to build them. And so basically we have rapid configuration files, we have Blaze build files, and they work together in order to build all the build artifacts needed for a release. And one of the things Rapid does is it specifies a unique build, it creates a unique build identifier. And this can be customized. We have default values in place because of we want our tools to do the right thing by default, but teams can override that. If they have a different naming convention they want to use, they're welcome to do that. But it's important. With Blaze, you can tell it a build identifier. There's a flag, you can pass it. And that allows you, when you're running a binary, you can pass it a -- version flag, and it will tell you basically information about how it was built. So this is a way, if you have a binary, you can actually relate it back to how it was built, which can be very important when you're doing troubleshooting, because there are logs that are created with what happened during the build, what changes went into the build, and that can be very important when you're trying to troubleshoot a problem. Branching. I always like to include this slide, and then I have Googlers tell me they don't think it's important, but I think it's important because as a release engineer, we actually spend a lot of time arguing about branching strategies. And do you release from mainline? Do you branch and release? Do you branch and release and roll back up? So here's what we do at Google, right or wrong, it works for us. All of our code is checked into a main repository, and we have a monolithic repository. It's very large. And so when we begin a release with Rapid, we actually branch from the mainline, and the build and everything is done from there. Once we branch, we're no longer using the mainline. New changes continue to go in the mainline. Changes do not happen on the branch. When we have a bug fix, however, we can explicitly, Rapid gives us a really easy way to specify the version numbers of changes that have gone into the main trunk into Rapid. And so we call those cherry picks. And so bug fixes are cherry picked into the branches when you find problems. You can also choose to go back and just re-release from head. But if you've done a lot of testing or we have some projects that are actually quite big, and you don't want to have to go back to head because so many changes have gone in since you began your release process. You only want fixes for the things you're trying to, that are broken. We have a technology called fast branches. And we create a branch instantly. It's very, very fast. So the cost overhead with creating branches is very low, and so this is why we just do a branch for every release, because it costs very little. We create a branch using the revision number that's specified when we do the build. And then a reference is created to our source-based file system. And I'm not going to talk about our source-based file system, but there's been papers published on it. And here's an example of a path. And it's just a path. It looks like a regular UNIX path, but it's actually going through our source-based file system. And so the 1, 2, 3, 4, 5, 6 is the revision number in the source code repository. If the release process for some reason needs to make local changes to files, they get copied to the branch as needed. And so you don't have the overhead of having to copy everything that you're releasing into the release branch, because that can take a lot of time, particularly because of the way we do builds, when we build dependencies also. And so the number of files that can be required to release a specific product can be quite large. And this scales very, very well because the overhead is low. It doesn't take up a lot of disk space. It doesn't take up a lot of computing resources because you're not copying a lot of files. Testing. We've got a continuous test system, and it runs unit test every time a change is submitted to our source code repository. And the idea is you want to catch changes as quickly as possible. This allows us to catch many errors before changes are actually submitted. Well, you can do it before changes are submitted, depending on how you've set up your tree, but they absolutely are done after changes are submitted. During the release process, we rerun tests. And we get a lot of pushback from developers sometimes. They're like, well, I've already run all the tests in the continuous test system. Why do I have to rerun my test? And so we have a canned argument for them. One, the build flags that Rapid use may be different than what you're using in the continuous release system. Both systems have default set of flags. Often in the continuous release system, we only build optimized binaries. In Rapid, we usually build both because we want the files with the debug symbols for troubleshooting, but we also want optimized binaries to run in production. So the build flags are different, and being release engineers, we're paranoid. You know what? If the flags aren't the same, it's not the same binary. You know, and the test targets might be different. Often the build language for doing the continuous test and the build language for Rapid are the same. And sometimes the files are shared and the test targets are identical. Sometimes they're not. So we can't be guaranteed they're the same test targets. And so we want to be sure that we're running tests in the context of what's being released. And, you know, I talked about our branching. And once we do a cherry pick into a branch, that version of the code does not exist anywhere else. And so you can't rely on the continuous test that was run when that particular cherry pick was checked in. Even if it passed, that doesn't mean it's going to pass in your branch because the code is different. And so this is one of our best practices. We just require that the tests need to be rerun. Another reason for doing it that isn't technical is that now we have the results of the test logged along with everything else that happened during the release. So you can go in and verify that the test actually did pass. I gave a whole talk last year on Midas Package Manager. It's online if you're really interested in that. I like talking about package managers. I'm very interested in them. So I'm going to talk. I'm not going to repeat a lot of what's in that talk, but I'll repeat what I need to for the context of this talk. So MPM assembles packages based on Blaze rules, and we actually use Blaze to do our packaging. We can do a Blaze MPM. And Blaze will send the request off to the Midas Package Manager to actually assemble the package. So there's build artifacts. You specify which build artifacts do you want to go into the package. They can be Blaze targets. They can be specific files. Just whatever it is you need to be in that package when you install it. You can specify owners, permissions, and there's package metadata that's important when you look at the release process. There's the name of the package, and this is the actual name of a package, search Shakespeare front end. And the naming is hierarchical. And that becomes real convenient because we can actually apply access control lists at any point in the hierarchy. So I could apply an access control list to search Shakespeare and then search Shakespeare. I need to use a name I can pronounce. Shakespeare front end will inherit all the permissions that were in the parent. There's also a unique hash identifier. It's a really ugly numeric string, but it's unique across all packages. And then there's there's a package signer. We know who built the package and use that for authentication. So when we look at deployment, MPM labels become very important. We can apply labels to individual packages, and one way of using labels is to indicate where a specific package is in the release process. So when you do the first build, you might apply a label of dev. You do some testing on it, and you can promote the package maybe and apply a label of canary to it. Do some additional testing, and maybe you run some canaries out on the production machine. And then when you're ready to release it, you can apply another label, perhaps released. And it makes it real clear to anyone examining the MPMs where they are in the release process, and it also can be used to write rules for fetching and installing the MPMs. Rapid, I think I talked earlier about a unique build identifier that Rapid uses to pass to Blaze. We also use this identifier for applying label to a package. So that way, when we look at a package, we can tell exactly what Rapid release candidate built it. And that can allow us to go back and look at the logs, the error, and see if there were any errors, see exactly what was used to build that package, and that can be very useful for troubleshooting. And when you install a package, you basically have to have two pieces of information. You have to have the name of the package, and you need to have which version of the package you want. And that's basically the label. You specify a label. For a specific package, for example, for search Shakespeare front end, only one package can have a label of canary. If I apply the canary label to another MPM, a newer MPM, for example, with the same name, it gets removed from the old package and applied to the new package. So respecifying a name and a label is guaranteed only to match one package. So here is an architecture of our continuous build and release system. And this is the first time we've talked about this outside of Google. So in the, can you all see my cursor? Yeah, you can. So we have a Rapid client, which is a command line interface or a web-based interface. It talks to a Rapid service, which is running as a Borg job on our production machines. At the top, I talked about build configuration files that are used by the continuous test system and Rapid, that we call those blueprints. And they're used to define what targets are built. Often there's deployment information in them, and what flags to use. Then we have workflows, which are basically just ASCII files that define what should be done. Do you do a build and test and package? And then a deployment? Basically, what tasks should be run and in what order? And you can chain workflows together. This square in the center is basically the main worker. This is running in Borg jobs in our production environment. And it receives a work request from the Rapid service. It uses the blueprint files and the workflows to determine exactly what to do. And it basically farms work out to our external services. And so there's the test services, the build and package services. I have those in the same box because we actually have the ability to skip the Blaze build step. And we can go straight to the packaging step, and all the binaries get built at that time. And it actually saves some time in our release process. And all of these have access to the source code repository. And the branch basically, when it's created, it's submitted back to the source code repository, and that's actually what's being accessed here is the branch. And then their build artifacts. And the most common build artifact is an MPM. We have other types of build artifacts, but I'm going to keep the focus of this discussion to MPMs because it just makes the talk shorter. And then we have deployment services. And I'm going to talk about some different ways of doing deployment a little later in the talk. And so we have build artifacts. We also have build logs that are stored so that you can go back and look and see exactly what happened during the build. Let's see, and I see if I'd covered everything. You request a revision number to say, okay, I'm ready to do a build, and here's the revision number I want you to use. It's possible to say, hey, just release from Mainline, whatever the current revision is. Release from the last good build from the continuous test system. You can do that too. And there again, the project owners get to decide how they want to choose the revision number. Binaries and unit tests are executed. We can do this in parallel in order to reduce the total time of the release. And then I talked about that. Okay, I did cover all this. The change log is important because that can help identify problems. And if you're releasing quick enough, the change log is quite manageable and allows you to quickly see, okay, here's what's changed, which can help also with planning your system test plan. You can really focus on the new features that have gone in. Deployment. So we've already done our build, and we have an MPM that's ready to be tested. Rapid, we have the ability from Rapid basically to restart jobs using the new MPM. That's pretty quick. It's but it's very simple type of deployment. And if your jobs are running in many clusters, you probably don't want to use Rapid because some of them may fail. And the Rapid interface isn't the best for one, understanding you got a failure, and two, troubleshooting that failure. So I actually have some people in the meeting who actually worked on this product. We have a product called Sisyphus, which is as release engineers, this is our recommended way of using deployment. We love Sisyphus. It allows you to decouple permissions. Sisyphus has its own authorization mechanism. And so I can have permission to request Sisyphus to update a job, but I don't have permission to actually update the job myself. Sisyphus does it for me. And frankly, as a release engineer, I don't want access to all the different jobs out there that we support. That's too much responsibility. So what is Sisyphus? What is it? And feel free to jump in. We've got two of you engineers here. Yes, there's one there. Oh, are you taking pictures? Maybe you'll learn something. So it's a general purpose rollout automation framework, and it's very flexible. You can do, I think, almost any kind of rollout. I even ran across one team in the past week who were using Sisyphus to do their rapid builds, which then probably come back to Sisyphus, and I don't know if they have an infinite loop in there or not, but, Yeah, don't get me started on Buildifus. I'm not going to talk about Buildifus. It was developed by our SREs because they wanted a way to manage rollouts. And so there's Python classes that literally can support any type of rollout. If your rollout isn't here, you can use the classes to create a new rollout. It has a dashboard that's customizable, and you can use it to actually see the process of your rollouts in the different clusters. You can have it automatically start the rollouts, or you can wait, have it configured so that maybe you start a few of them, but then you manually go in and start the rest of them after you've had successful rollout. So it's extremely flexible. I used to be on the search team, and I used to do the Google web search pushes, and which was really kind of exciting because you're like, oh my God, I'm affecting the whole world. I'm pushing. I'm like, okay, Europe, have a new Google web search, and it was actually, but we use Sisyphus to do that and manage it. So the integration with Rapid, you have a Sisyphus job that's running in production, and then Rapid can request a rollout, and it tells Sisyphus, oh, this is the build label for the new MPM, and this is the one you should use for this deployment. And Rapid doesn't have to know anything about the deployment. It doesn't have to understand how Sisyphus is configured. All it does is it knows which job it's supposed to update and the type of rollout it's supposed to request, because rollouts can have different names, and the same Sisyphus job can support different rollouts. Okay. Okay, thank you. So the rollout process, you can update all the jobs at once if you're brave, or if you're not running in a lot of clusters, you can just update them all. Particularly if it's a service, if it's an internal service, maybe it doesn't matter, or if it's a type of job where you can just do that without having to worry about interruption of service. Or you can roll out over a longer period of time. Do I talk about? Yes. So you have to match the risk profile. It would be really bad if we updated Google Web Search all at once. We're just not going to do that. There's controls in place in the way the Borg jobs are configured. We're actually, even if you request that, it's not going to happen. But we're not going to do that because we want it to stay up. I talked about some teams build hourly. Well, they might build hourly and push every job to a test cluster. And every build to a test cluster. And if they do that, then they can start testing and finding out if they have any problems right away. But it's a test cluster. We don't care if it goes down. There's no customer-facing outage. We have a concept of exponential pushes, where you might roll out in one cluster, then 2 clusters, then 4 clusters, and so on until you've pushed out to all the clusters. We also often will pick different geographic locations, and this is very useful for language issues. I used to do the builds for iGoogle, and we always wanted to make sure we got different geographic coverages to make sure we hadn't introduced a problem with internationalization. Okay, yeah, how much time do I have left? I don't have much time left, I'm sorry. Okay, so I'm going to talk about releasing binaries and configuration files. Our approach has changed over time, and actually we have more approaches over time, and different teams swear by their methods, and teams don't agree. So I'm going to talk about 4 different mechanisms. One of them is where we just have configuration files in the mainline. So the idea is you've got binaries, and you've got configuration files that the binaries need in order to understand how to run or what to do. You can put configuration files directly in the mainline, read them from there. This has the advantage of changes are available as soon as they're submitted. It has a disadvantage that you have to update the job to pick up the changes. And you can end up with a skew because if all the jobs don't get updated, you may not realize that. And so you have some jobs that are behaving differently because they didn't get the new change. But we do this a lot. And the binaries and configs are decoupled, so they can have different release cycles. You can also package the binaries and configs together. This works well if your binaries, if your configs change with every release at the same cycle as your binaries. So you package them together. There's only one package to fetch. It tightly binds the binary with the configs. This work, and it makes it for a simplified deployment. If you find you have to make a change, you have to cherry pick a config, you have to rebuild the binary because Rapid will rebuild the binary every time you do a new build because the build ID changes. We also have configuration-only MPMs. And this allows us to have different release cycles for the two. And we can use MPM labeling to tie them together and indicate that these 2 MPMs should be fetched at the same time. And we also store configs in external stores. This is great if you have a file that's changing frequently. Like we have some that change like every 15 minutes. We can store them in Chubby, Bigtable. There's been papers written about both of these if you want to know more. And our source file system. We have multiple options for almost everything. And at Google, if you don't like the way something works, you write your own. It's part of our culture. So I'm going to skip my personal conclusions to allow time for questions. But first, I have 2 shameless plugs. One is we're having a summit tomorrow, Release Engineering, that begins immediately after the keynote. And your Google badge gets you into this. Oh, Yeah, it's only for Googlers, sorry. And here's a couple of links to references on where you can see the program. I'd love it if you all dropped in. My shameless plug number 2 is, I don't like the way it turned. Anyway, Google has written a book on site reliability engineering. And I was honored to be a part of this, and we expect it to be published in early 2016. And so I've read it. I think it's very exciting. I learned a lot about how we do site reliability engineering, even though I'm internally in Google. Also, third plug, there is a BOF on release engineering after the reception. I don't know what I was thinking. I don't have an agenda. I'm just hoping that people interested in site release engineering will show up. Yes?
There's a second one after the USDS because there's at least 2 of us that wanted to go to the USDS and your release engineering one, so there's not 2 release engineers as well.
Okay. And questions?
So if you have questions, please use the mic in the middle. Please go up there if you have any questions. We have 2 more minutes for questions.
And I'll be around. Show up at the BOF if you want.
How does what you're doing now differ from, like, over the past 5 or 10 years? How has it changed? Like, how is what you're doing now different from what you're doing like 5 or 10 years ago?
Well, for one thing, even 5 years ago, we didn't have Rapid. And if I wanted to do a build, I had to do it on my workstation. And I didn't have we had a user interface for one of the tools we were using, but it was very difficult to hand off mid-release to someone else. And so now we have a tool where anyone who has the permissions can pick up mid-release and finish it. Plus, we didn't have the logging and the integration with some of the tight integration with some of the tools. And we didn't talk a lot about release velocity because we were too busy trying to do releases. I've seen release engineering change a lot in that now we're focused on the how and how to do it better as opposed to actually doing it. And so our goal is to releases should be automatic. And that's a goal within SRE also. We want SRE to be automatic.
You're collecting a lot of data about the build and release process. Are you using that data to more intelligently tune the system itself?
I didn't quite understand that.
You're collecting a lot of data about the source code and the build process and times and everything about. Are you using that data to help optimize the build and release process?
Absolutely. Absolutely. We're looking at everything from how long does it take a change to get into production? What's the build frequency? We have a mandate now, which is a new thing, talking about new things. We expect I can't say what the time frame is, but we actually have a time frame by which binaries must be rebuilt so that we guarantee that we don't have stale binaries running in production. That's new for us. And then we have ways to measure this now that we didn't have. We worry about we have a tool we've just created that I can't talk about yet in detail, but basically we've defined best practices for our product area on things we expect to find in a rapid project. Because I support over 1,500 rapid projects. It's impossible for me to go in and manually inspect all of them. But we want to make sure that people are using consistent, reliable processes. And frankly, my experience has been most engineers really don't care how their rapid project's configured. They care what it does. And so we're learning a lot, and we're trying to continually improve how we're doing things. And my goal is to make it so that people don't worry at all about their release processes. Right now, people still have to worry too much about their release processes.
Thank you very much.
Thank you.
She'll be around later if you have any more questions. Happy to talk with you in the halls, I'm sure.